Good evening, everybody. I hope everything is going well for you and all of you are in complete health. Um, as Mr. Elias told, yes, time is past and we need to give importance to time. Because every session, some students interclass in middle of time and they tell me we don't understand the beliefs and please explain again because we have delay, and so this is the reason I waiting a little for rest of students to come class. But today I want to start class because at first I should tell you. Today class will finish sooner than normal time, and I'm so sorry about that because I should go and do something and I have to leave class today sooner than normal time. I'm so sorry about that, and I hope make up for it. Today I give you the new lessons, and next week we should solve the problem, and we should do more exercise about the lessons that I want to give you today. And our subject today is related, as you see, our subject is a statistical process control. And this subject has some mathematical formulation such as the forecasting and decision-making tools. And also we have to do more exercise for better understanding. So today I give you this lesson, and we try to focus on concept of the statistical process control. And next week we do only exercise about this for your better understanding. At first, please let's to be familiarized with concept of statistical process control. At first, before starting this lesson, please let me give you an example. Everybody can hear me? Oh, Mr. Asman, I think your internet has problem. May I ask you check it again, please? Because your friends can hear me, only you cannot. Please check your internet and your speed of internet. I think your internet or computer has problem. Okay. Before starting this subject, please let me give you an example. Imagine you are a manager of a company which is producing clothes such as the T-shirt, such as the pants, such as the and some dress and something like this. One of the most important operation manager's duty is that control the process of the production. For example, when the machine is working and the laborers, the beside of these machines are considering and are examining the machines for producing, they should consider this point that sometimes some of the products are defective. And this being defective can be for a variety of reasons, such as the labor's mistaken, or such as the machine has broken, or something like this. And the product or the goods that are being produced have problem, are defective. And in this time, in this moment, the operation manager should stop and should stop the process of the production and start to examine the reason of the problem or being defective of the product. So after examining and after finding the problem, they should, for example, they should fix the machines, or they should give warn to laborers to be careful about the production, and after that they should start again the process of the production. For control of process and for control of the process of the production, or for considering the quality of the production, there are some methods that the operation manager can use. They should use the sample, for example, in a specific time. For example, every 1 hour or 1 hour to 1 hour, half an hour to half an hour, they should choose sample from the production and they should check them, and they should consider them to see whether they are defective or have problem or not. If they have not problem, they can continue the process of the production. But when they see there is problem in the sampling that they have selected from the production, they should stop the process of production and start to investigate to reasons for problem or defective of the product. So one of the statistical process control refers to methods that can help the operation manager to see whether the process is under control or not. A statistical process control, as I give you, this is it was a good example. For example, because when you are working in a company as an operation manager or as a quality manager, they should control the process of the production. For example, as I told you, you are producing clothes, okay, such as t-shirts. The designer has designed, for example, t-shirts with a specific color, with a specific size, and for example, they have told the size of for example, the sleeve, the size of for example, the wrist, and the size of these shouldn't be exceed, for example, from this quantity, from this number. So the machine starts to producing these t-shirts or these pants or something like this, and the machine is able to produce, for example, 500 t-shirts per hour. If operation managers wants to the production is under control, and every t-shirt has been produced is exactly the things that the designer has designed, they should control the process. They have some methods for control the process. Okay, for example, they should select sampling from, for example, as I told you, the machine is producing 500 t-shirts per hour. Operation manager or quality manager select 10 or to 15 t-shirts from out of these 500 t-shirts and go to laboratory and test these to see the size and the color and everything is exactly accordance to a standard that designer has designed or not. If the size has problem, it shows that the process of the production has problem. This problem can be for variety of reasons. For example, machines has broken. The machines is producing the t-shirt has problem, or sometimes the labor has mistaken and the labor has done something a mistake and has caused the t-shirt Mr. Ahmed, this is the first slide. I haven't started. I'm giving you example to be familiarized with this subject. The subject is related to a statistical process control. A statistical process control is about the control of process of production. Because there are some methods, some statistical methods that can help to operation managers to see the process of the production is under control or not. For example, operation managers are working. For example, are working in a textile company that is producing, for example, clothes or producing T-shirts. Okay, T-shirts. The designer has designed T-shirts for a specific size. For example, this size should be considered in this. The color should be, for example, like this. The size of the color, the size of the sleeve, and something like this should be exactly like this. Okay. The machine is producing the T-shirt, and for example, per each hour, the machine produces 500 T-shirts per hour. We want to see the process is under control or not. The process is under control means the machines which are producing these T-shirts, has not shouldn't have problem. The size should be exactly similar to size that the designer, the engineer has designed. The color should be, for example, like this, and everything should be checked. The size, the color. If the size has the problem, if the size is not as same as the thing that a designer has told you as operation manager, it means that the machine has problem or the labor is doing mistake. So the process of the production is not controlled. Operation managers should stop the control, the process of control, and examine and start to examine what is the problem. The machine has broken, the labor is doing mistake. What is the problem? Because the T-shirt has problem. This T-shirt, how the operation managers understand the process is not under control? How the operation managers understand the T-shirt has problem? There are some statistical methods that can help to operation managers to understand the process is under control or the production has problem or not. We want to be familiarized with the statistical process control, a statistical method. Okay. In this lesson, we want to be familiarized with a statistical method that can help operation managers to see the process is under control or the production has problem or not. Okay. It's very interesting topic today. Before familiarizing with a statistical process control or a statistical method, we should be familiarized with some concepts. Okay, at first, please look at the slide number 2. Variability is inherent in every process. Natural or common causes, special or assignable causes. Okay. This is a fact that all of the products that are produced in 1 hour. For example, as I told you, the machine has produced 500 T-shirts in 1 hour. If you check all of the 500 T-shirts, you can see that some of them are different from others, and all of the 500 T-shirts are not exactly the same. For example, inside of the sleeves, for example, in length of the sleeves in one of the T-shirts is, for example, 10 centimeter. In one of them is 10 centimeter and 1 millimeters, for example. In another one is 10 centimeter and half another millimeter. If you check all of the production are not exactly the same. So this is the reason that we say the variability is inherent in every process, is natural in every process. But sometimes this variability is not natural, is not normal. It shows that the process is not under control and there is something problem. So the variability The variability in production can be divided into two categories: natural or common causes, special or assignable causes. If the variability or or being different in product is natural, we cannot do anything. The operation manager cannot do anything because it's natural. It's out of control. It's inherent for many. It can be for many reasons. Okay, but some of the problem is the special or assignable causes. If the problem in production or if some of the products are defective, if some of the products are defective and this defective is special or assignable causes, so there is a problem, and operation manager must stop the process of the production and must start to examine to what is the problem. So the variability in the problem. So please let me tell again. All of the products are not the same, exactly are not the same. They are different in production. This different can be natural or common, and operation manager cannot do anything because it's natural and this is out of control. But some of the different or some of the defective are special or assignable causes. This is for some reasons, such as the machine has broken, the labor is doing something mistake, and something like this. And this is the reasons that some of the product has considerable defective. So operation managers must stop the process of control, the process of production, and start to examine what is the problem. Okay. Statistical process control provides a statistical signal when assignable causes are present. Okay. So the statistical method tell the operation manager the production are defective. Yes, very good, Mr. Elias. Exactly. It's called assignable because the operation manager can assign someone to work, or assign something or some product, some problem to process of control. It can be measurable. Okay, it can be measurable means that it has a reason that this process is not under control. So operation managers should. This is the reason that a statistical method is only for the states that there is a special or assignable causes. Because, as I told you, for natural or common causes, we cannot do anything. So, a statistical process control or a statistical method shows only there is a special or assignable causes in control. Okay? Please listen carefully. A statistical method shows and tell the operation manager there is a special or assignable causes or problem in machines, and process should be stopped. And in other words, the statistical process control detects and eliminates assignable causes of variation. Detect and eliminate assignable causes of variation, not natural, because we don't involve the natural or common causes, because this is natural and this is not concept. Okay, natural variation, natural or common variation, also called common causes. Another name of the natural variation is the common causes. Affect virtually all production processes. Expected amount of variation and output measures follow a probability distribution. For any distribution, there is a measure of central tendency and dispersion. If the distribution of outputs falls within the acceptable limits, the process is said to be in control. In the natural variation, we should use the statistical methods or a statistical formula. In a statistical method, and we have the normal distribution. When the operation manager is working with SPSS or the other software that is related to a statistical, the operation manager should select a sample from the production and measure them, and after measuring and analyzing the data or sampling, they can see if all of the data are in limited and allowed limitation or acceptable limitation, the process is under control. Or if there is not something like this, this is not natural variation. This is the special or assignable variation. And as I told you, the process should be stopped. Assignable variation, also called a special concept of variation. Generally, this is some change in the process. This is some change in the process. Variation that can be traced to a specific reason. As I told you, operation managers should stop and examine what is the problem or what is the specific reason of this defective or problem of the production. The objective is to discover when assignable causes are present, eliminate the bad causes, incorporate the good causes. And this is important for every operation manager, should eliminate the bad causes. And after eliminating, they can continue the production. Control charts. One of the statistical methods that can be used by operation managers is control charts. These charts are statistical process controls that can be used by operation managers, through which operation managers can understand the process is under control or not under control. For doing this, one of the most important duty or one of the most important things is the operation manager should select sampling. For example, if the machine is producing 500 t-shirts each hour in a company, in a factory, operation managers or quality managers can select, for example, 50 t-shirts out of 500 t-shirts and go to laboratory and test it and measure them and collect data. For example, the size of the color, the size of the sleeves, and another data that are related to t-shirts and or any clothes. Okay, this is related to production. After that, this data can be drawn on a chart. The data of the sampling should be brought on the chart, and these charts can tell the operation manager the process is under control or not under control. Okay. There are some shapes that can help the operation manager. In the above, there are 3 diagrams that can show in a statistical control and capable of producing within control limit. It shows if when all of the sampling can measure and all of the data are analyzed by software. For example, this diagram shows the process is under control or not. If you see it in the shape A, the process is under control because all of the diagrams are in parallel of each other and they are located in between 2 dot lines. In the shape B, the process is under control, but the operation manager should be careful because in the future the process can be go toward being uncontrolled. Okay, this is in the border, and this is in the risk. This is under control, but it's going to become a risk for company. But in the C, this is the out of control. As you see, the diagrams are not the same, and they are located in out of the control. They are located in the out of this parallel line, dot line that you see. We will be familiarized with this in the future. Okay, don't worry about this. Type of the data. Types of the data is or variable attributes. Variable are those data can be measured, such as the length, such as the weight, such as the mass, and something like this can be directly measured by a tool, such as a scale, such as a meter. But attributes are those of the variable or another variable. They are not variables, but they can be measured, but not directly by a tool. For example, for IQ, if you want to measure your IQ, intelligence quality, okay, you cannot use the directly to you cannot measure this directly. You can use, for example, the IQ test, and after that, by using the test, you can measure your quality, your IQ. Or for example, if you want to measure the hard working of a person, the hard working cannot be measured by use of the sum variable, such as the number of the for example number of the hours that a person study per each month, per day, sorry, per day. Yes, exactly. Variable is Mr. Elias right in Farsi, in Farsi language. قابل پیمایش and non قابل پیمایش. Exactly as you see. Control charts for variable. There are four charts. That can help operation managers for control control of the process of for control of the process of production. These charts can help the operation managers to see whether the process is under control or not. The charts, the operation managers, with regard to the type of the production, for example, if it is t-shirt, sometimes it is the industrial production, such as the parts for automobile, and such as the appliance, electrical appliances in the kitchen, and something like this, and it depends on the type of the production. The weight, speed, length, strength, and something and many variables can be measured by operation manager in laboratory to see the process is under control or not. For example, operation manager choose the weight of the, for example, the weight of the production to see as a criteria, as a for example, as a benchmark to see production, to see the process of production is under control or not. This is the hand of the operation manager, and it depends on type of production. Weight, speed, length, strength, and every variable can be used as a benchmark or as a criteria in laboratory for operation manager to see the process is under control or not. We can give an example in future for better understanding. Okay, X bar chart and R chart are two control charts that can be used for a variable and that can be used for operation manager to see the process is under control or not. X bar chart and R chart has their own formula and has that for us to see which one is should be considered by operation manager. Please let us see the next slide. At first, consider the X bar chart. X bar chart, as I told you, is one of the statistical methods, or it's one of the charts that can be used for measuring the process of the production to see it's under control or not. X bar chart can be drawn in a coordinate system, y-axis and x-axis. At first, we should measure and we should calculate two limitations: upper control limitation and lower control limitation. Upper control limitation can be shown by UCL, and lower control limitation should be LCL. Okay, this limitation should be calculated and should be drawn in the chart if to see all of the data. For example, the weight, the strength, the length, the speed, and every variable is being measured by operation manager. When the operation manager measures the, for example, speed of the production in laboratory, operation managers, they wrote the data or the speed in their charts. If all of for example, this data, if all of the data are located between the upper control limit and lower control limit, we can say, for example, the process is under control. So in the X bar chart, we should calculate at first upper control limit X bar plus Z sigma X bar, and lower control limit LCL equal to X bar minus Z sigma X bar. X, Z, sigma X, and sigma N, and all of them have been defined in this. X is the mean of the sample mean, or standard value set for the process. Z is number of normal standard deviation, that is this formula is related to statistical science. You know, the persons or the students who are studying the statistical can understand this formula. You don't need to focus on the formula and understand each of them, because some of them have background in the statistical. If you can understand, you can refer to a statistical textbook, and you can ask a person who is field of statistical at university. X is the mean of the sample means. For example, as I told you, for example, the company is producing T-shirts. Please let me give an example T-shirt again. 500 per hour. Operation manager select 20 T-shirts out of the randomly. No need to memorize. No need to memorize. Only understand the formula. Okay. Please let me. I should give you example to understand this formula. For example, as I told you, the machine is producing 500 T-shirts per each hour. 1 hour to 1 hour, the machine is producing. Operation manager or quality manager should select 20, for example, T-shirts per each hour from 500 hours. For example, in 9 o'clock in factory, the work started, and in 10 o'clock, machines have produced 500. Okay. Operation manager selects 20 T-shirts out of 500 and go to library and start to measure the size of the, for example, sleeves and something like this. In 11 o'clock, exactly do the same. In 12 o'clock, exactly do the same. 1 hour to 1 hour, operation manager should select 20 out of 500. Every time, operation managers do this, because until end of the time of the, for example, finishing work, the time of the end work, the operation managers must do this every 1 hour to 1 hour until the business hour finish. For example, 6 o'clock p.m. The machines turn off and labor leaves the factory and go home. From 9 o'clock or from 10 o'clock until 6 o'clock, every 1 hour that machine producing 500, operation manager also should select 20 in each per hour, 20 out of 500 per hour, because it must control every hour on all of the process of the production until end of the business hour. Okay, so the sample size N. Mrs. Aliza, do you have my voice or not? Mrs. Aliza, do you want to log in again, please, and check your computer, check your speaker. It's not off in your computer. Please go to control panel and check. Okay. Please check everything and your internet speed, and if there is problem, please let me know. Okay. Okay. After, as I told you, every hour machine is producing 500. Every hour machine is producing 500 t-shirts, and every hour operation manager select 20 t-shirts as a sample randomly as a sample out of 500, and go to laboratory and test it, and write down the data of the size. For example, the size of the sleeve is important for operation manager. It the t-shirt number 1, the size of the sleeve is, for example, 10 centimeter. T-shirt number 2 is, for example, 11. T-shirt number 2, for example, T-shirt number 3 is 4 is until 20, because it has selected 20. The operation manager writes down the 20 number as a mean, as a sample mean. Okay, and also, for example, in 10 o'clock a.m., operation manager has selected 20 t-shirts and measured all of the length of, for example, the sleeves, and write down the all of the data. It has written down 20 number as a size of the sleeve, length of sleeve in a, for example, table. This is the sample means. Okay, the sample size is 20. N here is 20. If you see the look at the slide, N sample size. Sample size is 20 because operation manager has selected 20. Sigma is population standard deviation. As sigma and is a standard deviation of the sample that can be calculated sigma divided by N. They are the definition in statistical, and it can they have not for example, they have not a special meaning because they have defined in statistical and they are constant. For example, the z can be equal to 2, 3. They can use yourself 2 or 3, and this is it depends on the accuracy of the production. For example, how much do you want to consider? How much do you want to consider the accuracy? You can select, for example, z or number of normal standard deviation. Normal standard deviation can be z equal 2, 3, their standard. Okay. And according to accuracy of the production, because some of the production are dangerous, and the engineer has told the operation manager it must be, for example, this size must be considered, and if you select, for example, the sample and go to laboratory, and when you see the size is not the same as the size that I have designed for you, please immediately stop the process of the production because they have problem. It depends on the type of production. As I told you, some of the production are dangerous and they are related to, for example, to aviation industry, automobile industry, and something like this, and they should be exactly the size of the production should be the same as exactly the same as the engineer has calculated and told to operation manager. So in the X bar chart, we must calculate two limitation: upper control limit X bar and lower control limit X bar minus Z sigma X bar. Z is constant. Z can be 2 or 3. We be familiar with it. And sigma X bar can be calculated as formula sigma divided by n. Z and sigma can be given by operation manager, and they can choose from the table. And after that, the n is the sample size. It depends on the operation manager how much, for example, or how many how many t-shirts, how many production he or she select as a sampling. Okay. Setting control limits. Here, I give you an example. This example is related to a food industry is producing the oat flakes. Oat flakes, if you search in internet, you'll be familiar. It's related to oat is a kind of the grain, and flake is the, for example, the wheat flake, the barley flake. They can be used, for example, in soup, in food industry, in something like this. A company is producing the oat flakes, and operation manager wants to measure the weight of the flakes. So the meaning of the size is weight here. The mean sample is weight, and the weight is very important and should be controlled. If the weight is out of control, the operation manager must tell stop the process of control, because the machine is producing the flake the out of this weight. That is not a standard. Sigma equal is 1. Sigma is given to you in the exam or in each company. The sigma can be given by the engineer or something or another person that has designed the production. Sigma and Z can be given to operation manager, and it's enough to operation manager do with the sigma and Z that are has been clarified by the engineer. In this example, if you see sigma equal to 1 and Z is equal to 3, okay. With this sigma and with this Z, in other one, for example, in 9 o'clock, operation manager has selected 9 glass or 9, for example, a cup of the flake and has measured the weight of these cups. The cup number 1 is the 17, for example, ohms. It's a unit of the weight, ohms. Okay. Cup number 2 is the 13 ohms. The cup number 3, the weight is 16. Cup number 4, 18. Number 5, 17, 6, 16, 7, 8, 17, and 9 is 16. We should calculate the mean of these 9 cups. The mean is 16.1. If you sum up this 9 number and divide it by 9, you can gain this number 16.1. Okay. In the 10 o'clock, the operation manager has selected 9 cups and has measured the weight of this 9 and has calculated the mean of these 9 cups. If you look at the table on the right, yes, the average weight produced exactly for the oat flakes. In the over number 1, for example, 10 o'clock, the mean has become 16.1. 1 hour later, for example, in 11 o'clock, the operation manager exactly do the same and exactly randomly select 9 cups of the weight and again again measure the weight and again measure the mean of these 9. For example, the mean has become 16.8. In the 1 hour later, for example, 12 o'clock, operation managers do the same and the mean has become 15.5. 12 times, for example, from 9 o'clock until 9 o'clock a.m. until 9 o'clock p.m. 12 times, operation managers do exactly the same. Exactly. Each hour, 1 hour to 1 hour, operation manager select 9 cups of the flakes randomly and measure the weight of this cup, these 9 cups, and after that measure the means of these 9 cups. Exactly this. Please have a look at the hour 1. Hour 1 is for example 9 o'clock a.m. It's hour 1. In hour 1, 9 cup has been selected and the weight of oat flakes in each cup has been calculated, and after that the mean of these 9 has been calculated by operation manager. For example, 16.1 is for the hour 1. In the hour 2, hour 3, 1 hour later, 1 hour to 1 hour, exactly operation managers do the same. Okay, until 12 o'clock. Now, until by calculating this, the upper limitation and lower limitation UCL and LCL can be calculated. X bar. These numbers in the table on the right. Okay, the table on the right in the for example the other one, the means is 16.1. The 16.5 is X bar, not X bar. It's X bar because it's the mean of the 9 cups. The 16.8 is the mean of the 9 cups. In the other 3, the 15.5. The 15.5 is the mean of the 9 cups in other 3. In the other 4, 16.5. In the other 5, the 16. These numbers are the X bar, not X bar. X bar is mean of the X bar. It depends on the operation manager. For example, you can do it in 2 hours to 2 hours, 3 hours to 2 hours. But for better control, it's better to, for example, 1 hour to 1 hour you select sample and go to laboratory and measure everything. In this example, this is an example. We don't know, but we cannot. We don't know what is the favorite weight, what is the desired weight for operation manager. We don't know, but we can tell the operation manager this is under control or not. X bar is the mean of this 12 number. Okay, we have 12 number here: 16.5, 16.8, 15.5. 16.5, 16.5, 16.4. We have 12 means of the 9 cups of here. If the sum of these 12 numbers and divided by 12, we can calculate x bar bar. X bar bar can be shown that x that are two lines above of x. You can, if you see the formula UCL x bar equal to x bar bar. X bar bar means x with two lines above of x. If you sum up these 12 numbers, these 12 numbers are x bar. Okay, each of this number in this table are x bar. If you sum up these 12 numbers and divide it by 12, you can calculate x bar bar. That means of the means of x. This is x bar bar. This method can be used for all of the production and for all of the factory. No problem. This is food industry. This is the automobile industry. At first, you should calculate means of the, for example, because for example, if you as I told you, for example, in the factory of the t-shirts, when the operation manager selects 20 t-shirts out of 500 in hour one, okay, in the hour one, it should calculate all of the size of the sleeve. When it calculates the size of the 20 t-shirts, it should write down there, for example, in the other one, the means of the 20 t-shirt is, for example, 11, is 12, for example. In other two, the means of the 20 t-shirt is like this. In other three, the means of the 20 t-shirt is like this. And after that, for example, when operation manager write down the means of the 20 t-shirts, at the end, it should sum of all of the means of these 20 t-shirts and divided by 12 to calculate the x bar bar. Here we need to calculate x bar bar. 99.73 is the accuracy number. Accuracy number should be given by engineer to operation manager. For example, operation manager give the this is the number for engineer. For example, engineer give the tell the operation manager work with z equal 3 and sigma equal to 1. Z equal 3 means the accuracy should be 99.73%. It means that all of the means accuracy of all of the means should be 99.73% near to exact number. This is the error. Okay, the accuracy of the projection should be 99%, more than 99%. It means that the accuracy should be very, very much, because it's, for example, it's very sensitive. The projection is very sensitive. The Z and the sigma can be given to operation manager by engineers. For example, engineers tell, I have designed this part so that the Z should be equal to 3. The Z equal to 3 means that yes, exactly. This, as I told you, this is the statistical and should be given by engineer to operation manager. Yes. The other number 60.8, 60.8, 60.5 is the means of the 9 cup of the flake in the next hour. For example, 60.1 is for the 10 o'clock. 60.8 is for 11 o'clock. 1 hour to 1 hour, the operation manager should select 9 cup of the flake and measure the weight of them and write down the means. After means, at the end of the no. Here, operation manager should select. Should select, for example, himself or herself should select 9 cup of the flakes randomly. Randomly, it select the 9 cup of the flakes, and after that measure the weight of each cup and write down in the table on the left. After that, for example, in the 10 o'clock, in the hour 1. After that, it should calculate the means of this 9 cup and write down, for example, 16.1 is for 10 o'clock or hour 1. 1 hour later, in the 11 o'clock, the operation manager should select randomly 9 o'clock, and 9 cup of the flex again, and again calculate means and write down in the over 2. In the 12 o'clock over 3 or over 3, operation manager should again, but the real data should be given to operation manager by the engineer. For example, after analyzing and calculating this sample by operation manager, it should compare this data by the data that engineer has given to him to be calculate how much is error. This is the same this data or not? Okay. Please let me. I tell you, x bar is the means of this 12 number. It means that please let me write here. Please let me. Please look at the chat. The 16 is x bar that has been calculated like this. X bar is mean of the mean. Okay. Z has been given by engineer is equal to 3. We write the 3. Sigma x bar can be calculated by like this. Sigma divided by radical n. Sigma x bar, as I told you, sigma x bar equals sigma divided by radical n. N is 9 here because sample size is 9. Because in each hour we select 9 cup. When you select 9 cup in each hour, it shows that the sample size is 9. If you select the 12 cup, the sample size was 12. If you select 5 cup, the sample size is the number of the samples you select in each hour. Okay. Sigma is 1 here. Sigma divided by radical 9. Radical 9 is equal to 3. 16 plus 3 multiply 1 divided by 3. Yes, very good. N is n equal 9, Z equal 3, and sigma is equal to. No. This is the sigma x bar. Sigma x bar is sigma divided by radical n. Sigma is 1. Okay. Sigma is 1. Divided by radical n. N is 9. Radical 9 equal 3. So it becomes 1 divided by 3. Understand? Sigma is 1. Please look at the bottom of the slide. I gave you the sigma. Sigma equal to 1. Okay. Z is 3. In the parentheses, please look at the parentheses. 1 divided by radical n. Radical n is radical 9. Radical 9 is equal to 3. Radical 9 is 3. So it is 1 divided by 3. Yes, radical n. N here is 9. Sample size. Sample size is 9 because as, because we selected 9 cups. Sample size is me. Yes. Square. Yes, exactly. Square root of 9. Square root of 9 is radical. That is okay. Very good. Okay, we can calculate the UCL, the upper limitation, and we can calculate the LCL. X bar plus sigma sigma x is 17 ohms and 15 ohms. This is the limitation. Yes, the 15 and 17 are a border, are the limitation for the all of the data should be located in between the 15 and 17. 17 is the maximum number for weight of this, for weight 17 ohms, and the minimum is the 15 ohms. Now look at the chart. Okay, in sample 1, how much was the mean? Horizontal axis is the sample number. We had the 12 sample number here. Okay, because in 1 hour to 1 hour, we, for example, or half an hour to half an hour, or no problem. Half an hour to half an hour, for example, or 1 hour to 1 hour. We have the 12 hour or 12 sample here. We do in the how many times we have done? How many times we have done the sampling? 12 times. Okay, 1 hour to 1 hour. In each hour, we calculated the mean. Exactly. Now, please look at this. In the horizon axis, in this coordinate system, the sample number has been selected. This is a standard for all of them. And in the vertical, the UCL and the SCL, and the vertical is related to means. The means in the means of the each of the means of the mean in each of the sample in each of the time of sample. For example, in the sample number 1, the mean was the 16.1. Do you remember? Please look at it. The other one, or the sample number 1, the mean was 16.1. The other 2, or sample number 2, 16.8. We should mark this point here. In the sample 2, it was the 16.8. Sample 3 or sample number 3, what was the mean? 15.5, and we mark it with the blue circle in each sample until 12, and the 12, for example, is okay. We calculated the allowed limitation. Allowed limitation are the limitation that should be very good, Mr. Elias. We have calculated the upper limitation and lower limitation, and we told that all of the means should be between 17 and 15, because we calculated 15 and 17 are very good. Yes, Mr. Elias. If you see the chart, there's 3 points. Sample number 10, sample number 11, and sample number 12 is out of this limitation. So the process is not under control. This is the out of control, and so operation manager should stop the process of control and see what is the problem. Do you understand? It's very interesting, and it's very easy. It's enough we calculate the limitation, the upper limitation and lower limitation. Upper limitation and lower limitation are the allowance, or the, for example, or the allowed borders. That all of the points, all of the means should be located in this allowed area. If all of them are in the load area or in the limitation, we can tell the engineer the process is under control and there is no problem. But if some of the means is out of this control, we should tell the process is not controlled and there is some problem. There is a specific or assignable, for example, causes here, and operation managers must stop the process and check the process. Also, there is another formula. There is another formula for X bar chart. In the previous method, the sigma was clear. We know the sigma. Okay. But sometimes the sigma is not clear. For example, the engineer tells the sigma is not clear, and the sigma we cannot tell you the sigma. We can do without sigma. If the sigma is not clear and the operation manager doesn't know the sigma, we can do another formula for the X bar chart. The formula is the same: X bar plus A2 R bar, and X bar for calculating upper control limit. X bar plus A2R and X bar minus A2R. The R is average range of the sample. A2 control chart factor found in table. I give you table, okay? I show you table. There is a standard table. There is a standard table that can be used by all of the operation manager. And X is the mean of the sample mean. X bar is clear, as I told you. X bar can be calculated very easy. As I told you, A2 should be selected from table, and R bar should be calculated. I tell you how you can do it. This is the table. Okay, this is the table. Table tell you if the sample size is n sample size. If A2 should be A2 is the name of the A2 is mean factor. Mean factor should be 1.88. You should select A2 from the table with regard to a sample size. For example, if here the sample size is 9, the mean factor is the 0.337. Yes, exactly. The X bar chart, the R chart, I told you, the charts here are the tools that can be used by operation managers to see the process is under control or not. If the process is not under control, it means that the production has defective, has problem, and the process should be stopped and check the machine and check the labor or something like this to find the problem. I'm telling to you how you can work with this chart to find the process is under control or not. X bar chart is the first method of the chart, the first method of the statistical process control. The A2 should be selected from table. E4 and D3 is for another things that will be familiarized in the future, not now. Okay. Please ignore the D4 and D3 now, and also look at the A2. So A2 should be selected from with regard to sample size. For example, here is sample size is 9, so A2 is 0.337, for example. Now we change a sample only as an example to you. Process average, for example, imagine the process average X bar is 12 ohms. Okay, for example, this is another example. And average rate is the R bar is equal to 0.25. Sample size is n equal 5. When the sample size is n equal 5, if you see n equal 5, the A2 is 0.577. Please look at the table. The sample size is 5, so the A2 is 0.577. You can replace this formula. X bar has been given you 12 plus A2 has been extracted from table with regard to n equal 5, and R bar gives to you 0.25. UCL or upper control limitation has been calculated at 12.144, and LCL is for or lower control limit has been calculated to 11.857. It can be done as same as the previous formula with only there is only one difference. In the previous formula we know the sigma, here we don't know sigma. But the process is exactly the same. We calculated UCL and LCL and we zero in the we zero here, and also we mark the point in the sample number 1, sample number 2, sample number 3 until sample number 12, and after that we see all of the mark or all of the points are located in this limitation or not. If one of the points, if only one of the points is out of this limitation, we should tell the process is not under control. Average range or R bar can be, I will tell you in the R chart. Okay, R chart is another method that can be used for checking the process is under control or not. R chart is, please let me give you the explain you R chart in the next week. As I told you, some of you come to class very late. I told you some of the students I should leave the class pretty sooner than normal. I'm so sorry about that because I should do something and I should go out, and so I'm so sorry about that. Please let me explain the R chart next week, and next week I want to give exercise to you to solve in class for better understanding. Okay, next week I explain you R chart and I explain you what is the R bar, and you will be familiarized with this factor R bar. And after that, we want to do more exercise about the X bar chart and R bar chart for your better understanding. Inshallah, in next week. If you let me, I should leave the class today sooner than normal time. Okay, I give. Do you understand the first formula? Do you understand the first formula? Do you understand what is the UCL, LCL? I want to tell you. Do you generally do you understand what is the story of this subject? Generally. Generally, we want to see the process is under control or not. Okay. So there are some. Yes, we will discuss next week. I want to ask you a favor, please. Please have a look at this chart, this slide, please. Okay, and also have a look at your book, your textbook, because the studying before class can help you for better understanding. When next week I will explain you will understand better. I sent you this. I sent you yesterday this slide. Anybody received my email? I sent to all this slide yesterday. Okay. Okay. Please let me, before leaving the class, generally explain again. Company and factory are producing product. Okay, company and company or factory are producing product. Sometimes we want to see these products has problem or not problem. For example, imagine you are producing T-shirts, you're producing, for example, clothes in your company. You cannot leave the company without any check their product. We should check. You must, sorry, you must check the product that they have produced under a standard or not. If there is any problem, if you see any problem or defective in your product, you should stop the process of production and look for the source of the problem. For example, sometimes the machine has problem, and so it is producing the defective product or defective, for example, goods. It means that the process of production is not under control. So operation managers must stop the process of the production and look for what is the problem. The machine has problem. The labor is doing the mistake. What is the problem? We don't know. Just we know that there is any problem in our production because product has problem. For example, some of the products are defective. Some of the products has deformed. You know, they are out of their normal form. They have become deformation. You know. And something like this. For example, some of the color of the, for example, T-shirt has problem, or some of the sleeves has problem. This is not the size that we wanted to produce. For doing this, operation managers should check the process of the production every, for example, 1 hour to 1 hour, half an hour to half an hour, 3 hours to 3 hours. It depends on the type of production and something like this. Size, quality, yes, exactly. For example, the length, the speed, the weight, everything should be controlled. For doing this, there are some methods that help to operation manager to see the process is under control or not, or the product have defective or not. These charts can help to operation managers Yes, these charts can help to operation manager to choose sampling 1 hour to 1 hour. Operation manager select sample. For example, imagine the machine is producing 500 t-shirts per hour. 1 hour to 1 hour, machine is producing 500, for example, t-shirts. The operation managers don't have time to check all of the 500 t-shirts. So they need to select sampling. Sample, for example, only 20 t-shirts out of the 500 t-shirts. They select this sample and check only this sample. If these samples are okay, it shows that all of the 500 sample is okay. But if this 20 sampling that has been selected randomly, yes, randomly, they choose randomly. But if for example, this 20 t-shirt has been selected are not okay, it shows that generally the machine has problem, or there is a problem here. So operation manager should select the t-shirt and measure the size of the t-shirt. For example, measure the length of the sleeves of t-shirt, weight of t-shirt, or everything. They should choose a variable and measure this variable. And by use of this control, by use of these charts, they can understand the process is under control or not under control. It was a general of it was generally of the concept of this class. These charts can help the operation managers to do this, to see the process is under control or not. Okay, generally everybody understand? Okay, very good. Okay. Next week, I explain this chart, X bar chart, and R chart to you. Okay. Yes. I explain in detail and I explain more, and also we will do exercise together to understand how we can work with this formula and with this chart, X bar chart and R chart. Okay. I'm so sorry about I should leave this class. Sure, sure. We do more exercise, and I told you I'm at your service, and as much as you want, I will explain for you as much as you want, and don't worry. If you want, I explain you 100 times for you to understand, so everybody understand this. I think, for example, the forecasting and something like this, everybody understand, and I promise you that everybody can understand this also. I promise you. Okay. I hope everybody has have a nice night and have a nice time with your family. If you if anybody hasn't received, okay, sure. I will explain each some symbol for you in next week. Okay, sure. And if anybody has not received my email for this slide, please send to me email again to send back to him or her this slide. Okay. Thank you so much for everybody. Have a nice time and good evening and good night. Okay. Mr. Akmal, will you send to me email? Okay, Mr. Akmal, will you send to me email? I will send you a slide. Okay. Goodbye, everybody, and good night.